I thought about making a fun talk, but fun talks are hard, so it'll be another boring talk for me, 30 minutes of talking. No, hopefully it's engaging, especially after lunch. I didn't actually put sort of an intro slide, who am I, so maybe I'll just do that for a second. I've been working in open source for just over a decade, 12 years, I guess. Mostly in the container runtime ecosystem. So if you've used Docker, if you've used Containerd, those have been the projects I've been heavily involved in for, again, 10 to 12 years, which means I've been programming in Go for over a decade and been pretty comfortable there after, that initial kind of learning experience. So the talk that I submitted and was accepted to be on the schedule is really a personal experience of a project I've done at AWS, where we had a new initiative where we wanted to build a new kind of agent around driving containers, but the folks involved in kind of the early days of the project really wanted to use Rust. So again, it was my opportunity after a couple very failed attempts at going through the Rust book and sort of trying on my own to come up with reasons to write in Rust. I don't know if anyone else has that experience, but if you don't have kind of a real project to work on, it's hard to really invest yourself in a new language to learn. So anyway, it took me a while to really find something where I could really sort of sink my teeth in and really have to learn Rust. But this talk is basically the outcome of that experience, which is ongoing for me. So I wanted to give a little bit of the lay of the land. You heard that my work has basically been in the cloud native space. So the CNCF project landscape and sort of sister projects to my own are of interest. So I was going to try and hack together pulling this information myself, and luckily found that there's a website put out by the CNCF that's related to the landscape, but is a bunch of statistics about the projects in the CNCF. And so as you can see, and not surprisingly, Go is a very, very popular language. They have a couple different slices of this data. This is by number of repositories. So the Go line there says 500 repos. Over half of all repos in the CNCF are predominantly Go language projects. You can obviously see a lot of other languages here, and at the very bottom is Rust with 121 repositories and roughly, what does it say, 13.5% of projects in the CNCF are using Rust today. So the only kind of disappointing aspect of the sort of static data on this website is I'd love to know what it was a year ago, 2 years ago, 5 years ago. Maybe somebody out there has some interesting statistics, but I assume this is a number that was very much smaller 2 or 3 years ago and is now up to over 10%, which is interesting. Now, the other slice of that data that the CNCF provides is by amount of source code, which, again, as a measure is kind of interesting in that we don't usually think about source code in megabytes of content. But anyway, this was also there, so I thought I'd show it. I found it interesting because C++ far outweighs any of the other languages by amount of source code. And I think digging a little bit into the data, that's because the Envoy proxy, which is quite a large code base, is written in C++. There may be other factors, but again, Go is still fairly significant in the landscape of the CNCF, and Rust, again, by the amount of source code, which I found interesting, even smaller percentage of languages used in the CNCF. Again, like I said, I'd love to have kind of growth data on this because I assume, this is all trending in an interesting direction. I think there's a lot more interest in Rust. Case in point, this blog post that's now 5 years old, but written by one of the CNCF participants, just talking about increased use of Rust in the CNCF. They highlighted 3 projects, which I've never understood if there's a pronunciation for the key value store, TICV, I'll call it. Nobody's throwing tomatoes? Okay, we'll go with TICV. Linkerd, who again is writing more of their components in Rust, and OpenEBS, which was a sandbox project that had their data plane in Rust. Now, I did run a script just because I was curious out of the graduated and incubating projects within the CNCF, so that's 67 total projects. I wanted to grab their main GitHub repo. So, you know, a lot of projects have many, many repos. Maybe there's one for some utilities. Maybe there's one for a client for this language. So I was just curious, how many, you know, predominant sort of core repositories are using Rust? And that was an interesting data point that only 4 projects out of all, again, graduated and incubating projects have any significant use of Rust in the repo. And they're listed here, Envoy, Wasm Cloud, along with the ones that were mentioned in that blog post from 2020. Again, this is not pro or con any of the languages. It was just interesting for me to kind of try and understand from the data, like who's using Rust, who's adopting it, who's using it sort of as a core project component, who's making sort of an SDK that allows Rust users to adopt or utilize the project. And so, you know, for me, you know, coming to this sort of interest to write this cloud native component in Rust, because of this sort of limited scope of adoption we see at the moment, you may find things that I found as I, you know, built out this project. One is just the inability to use or kind of import common definitions or common sort of client components. And I'll talk about that in a little more detail related to Containerd. Many projects don't have a generated client. So if you think about, you know, something that has protobufs and a gRPC API layer, maybe no one's ever generated that in Rust so that you can easily import that crate and then start making calls to that component. And also you may find a lack of sort of common libraries. Like in Go, it's pretty easy to find a library that'll handle like an OCI image spec or an OCI runtime JSON component. And you can find lots and lots of code examples of people parsing those, getting, you know, pulling a piece of information or using them for something in their project. Again, there is good news here in that I found as I went along that people are creating these projects, creating some of these additional components for Rust developers. And so, you know, here's a very short list. Again, this is from my perspective because I was working with Containerd and container concepts. A lot of these core cloud native concepts do have initial kind of attempts at a Rust extension or library or client or crate that you can import and use. And so in Containerd, we have a project, again, a sub-project of our main repository called Rust extensions. And in that, we have a client crate. We have several companies that are actually using Rust to write shims that drive like runc, if you know how containers operate on the host, on a Linux host. And so this Rust extensions is a way for us to sort of have a common repo that collects up all the Rust components that you can use with Containerd. There's a nice OCI spec crate that lets you interact, you know, build up an OCI spec, pass it around, parse one. The Kubernetes project has a Rust client crate that, again, you can use to interact with the Kubernetes API and some of those concepts related to Kubernetes objects and the API interactions. OpenTelemetry has a Rust crate. So again, if you have a Rust program, you can actually use OTel components and do tracing and logging through OpenTelemetry from Rust. And then the Rust language itself has obviously many, many crates that just help you in the cloud-native world of parsing and creating JSON, doing protobuf generation or working with protobufs, working with gRPC, working with SHAs and digests. So again, this is all sort of late last year, early this year. I was happily surprised to see the things that I could adopt and use in my Rust project that are already available. Again, some of them are not necessarily from the core project. So if you think about the OCI spec, the Go language OCI spec specification SDKs, if you will, are in the Open Container Initiative's GitHub. This is, the personal GitHub of a developer in the Containerd ecosystem who's working in Rust. So I think we'll see maturity there, we'll see growth, we'll see some of those things adopted into the core places that define those specifications. But again, I found a lot of workable components that were mature enough and useful enough for what I needed to do. So again, my specific experience is that I wanted to use Rust to create a small Containerd client just to drive Containerd lifecycle operations. Pull an image, create a container, start a container, get some statistics from it, be able to stop and kill that container. So very, very simple things that I wanted to drive through Containerd's API. And in Go, we have a Go client that I simply import, and I can write a 100-line Go program that will do all these things fairly straightforward and fairly simply. Now, I'll take a brief, this is your AI minute part of the talk, since we all have to talk about AI these days. But for me, this was an interesting sort of side note to my Rust journey, is how much I benefited from being able to ask questions like, actually, maybe this is a little bit small, just things as I was learning. Obviously you can go through the Rust book and some of the great online guides, but just passing to an AI chatbot an error from the Rust compiler, which, as you all, if you're working in Rust, it puts out very useful error information. It makes it very easy to ask AI chat and usually get very good responses. But I also wanted to do things in an idiomatic way. I'm new to Rust, so asking what is the idiomatic way in Rust to take an error type from a result and construct the function scoped error type for a response. So again, these were just, I went back and looked at my history of all the things, this is like a fifth of everything I asked over a period of a couple months. But yeah, super helpful way for me to connect the dots in a language that wasn't as familiar to me as Go. So I mentioned, one of the helpful things coming from the Containerd project was this Rust extensions project, which, as I mentioned, is not just sort of one monolithic thing. It's a collection of crates. Here, I'm sort of down a few directories into the crates client subdirectory of this project, and you can see we have a crate that implements a gRPC client. This project, when it generates a crate, it also generates types for all the protobuf definitions from Containerd. It imports those from the main Containerd project. And so it's a nice starter for interacting with Containerd daemon from a Rust client. Again, just some comparisons, switching from Go to Rust. Now building a Containerd client, I don't have all those kind of helper functions that are in the Go SDK that keep me from really even thinking about gRPC. And again, that was a choice of the early Containerd maintainers, was to create sort of this rich Go client experience that many other projects consume even Docker, uses containerd. So Docker imports this Go client and makes many of its calls to containerd using that. And so I found myself writing definitely more code because some of that helper code is in this Go client library for containerd consumers. And so one of the outcomes of doing this project is like, I wonder how much I could contribute to our Rust extensions crate to start to add this layer of abstraction so that a Rust developer doesn't have to interact at the gRPC API level. So again, that's sort of a open source thought I'm having myself about making our Rust sort of client crate a richer SDK for Rust developers. And again, a lot of the time I found myself opening in my IDE the Go client SDK to remember, like start container is not just one API in containerd, there's a series of steps I have to take. What are those? And then assemble that sort of in my Rust client. And again, I think that would be a ripe area to sort of contribute into our Rust extensions crate to give Rust developers a level of abstraction that Go developers have. Again, just looking at all those charts about the CNCF and adoption of Rust, again, my assumption is it's definitely growing. I see more and more people working in Rust. But as that matures, at this point, you're probably an early adopter, and you may find bugs along the way. And so, there are people using that Rust extensions client crate, but they weren't using it in the way I was using it. So I found missing sort of pieces as I went along. And then I added some examples, contributed those over there so that other people coming behind me don't have to relearn those things. Again, a lot of it was simple stuff, things that had sort of not been tested, and some protobuf renaming that needed to happen to make everything work and line up. But again, you may experience that as well if you're trying to adopt some cloud-native technology that has sort of a new Rust interface that maybe hasn't gone through a lot of testing yet. So again, my perception from my several months of experience here is that Rust use in cloud-native is definitely sort of in an early adopter phase. You're probably going to find things missing. You may have to do a little extra work that again, if the source project is Go, maybe everything to that point has been geared toward Go developers importing in Go. Something I didn't talk about at the very beginning of the talk is really that, hopefully you're making language choices for the right reasons. There's definitely awesome reasons to use Rust. In the case of this project I'm referring to, it was very clear that Rust was going to be a great option for what we were trying to accomplish. You all are probably well aware of, some of the memory safety and the capabilities of Rust that make it a good kind of low-level language. And I think also, hearkening back to that initial data I showed, Rust adoption is definitely growing. It's definitely growing in the CNCF. But it's probably in pockets. There are specific areas where I think it's probably, being adopted more. Some of those projects that I listed that are clearly investing a ton in Rust. So again, it's very dependent on that specific area that you're looking to adopt or use as a client or integrate with your system. You may find sort of pockets of capability or ability at this point. And then I think, from an open source perspective, again, I've been contributing code to projects for, more than 12 years now. If you do start a Rust journey, maybe you're like me and this was all new to you, see where you can make it easier for people coming behind, contribute improvements, bug fixes, report things that you find, contribute some examples. Like in the containerd case, I'll go back to that for a second because that was kind of an interesting twist. Containerd and all container runtimes obviously need some way to talk to container registries. So if you've used containers, you've used Docker Hub or one of the major cloud providers registry or a private registry, and you mostly take for granted that Docker pull or Kubernetes pod deployment handles this image pull process. In Containerd, we've made that feature, so to speak, until our last few releases, a client-heavy transaction. And what I mean by that is that the Containerd daemon does not actually do the registry interaction. It's the Containerd client. And so this matches, there's historic reasons for this, but that meant that when you wrote a client for Containerd, again, naturally you might write it in Go. Our Go client library had all the logic for parsing the manifest and deciding the platform matching and then choosing the layers and then doing things like parallel pull of layers and the unpack. All that was done for you by the Go client library. So I was a little nervous knowing that when I came to Rust, we had a new feature called the transfer service, which does sit in the Containerd daemon and does allow you to actually call a gRPC API so the daemon can manage the lifecycle of pulling that image, doing all those steps I mentioned before. And so it was interesting coming to Rust, and first of all, there were some things that needed to be fixed in the client crate. But once that was fixed, the transfer service just takes sort of these opaque objects that's like a source and a sink. And that lets you implement interesting features like image conversion. It doesn't have to be registry to host. It can be image type A to image type B. So the transfer service was very pluggable and very configurable. And so I found a bunch of issues on the Rust extensions repo. Like, how do I use the transfer service? I don't understand. It just wants this generic object type. And so, of course, as a Containerd maintainer, I dug into the code. I talked to our developer who developed that. And I kind of figured out, okay, you have to, for a general pull transaction, you have to create this OCI registry object as the source and a local content cache as the sink. Again, not very straightforward things from a natural software development perspective. But it was great to figure that all out, to code that up, to see that it actually worked. And then I was able to add an example to the Rust extensions repo. So again, other people can understand, this transfer service is a nice way for me not to have all this client code about dealing with registries and let Containerd handle that. So again, you may, find similar things as you adopt Rust or move into a project that really hasn't thought through how other clients might work with how your main project works. So yeah, where you can, make the path easier. I've been wanting to write some blog posts about this, but I haven't had a chance yet. But again, however you're willing to share information on your journey, I think that's an awesome step to make sure we can continue to have new language support and support developers in those languages. So yeah, that's really all I had. And I know I'm a little short on time. We've only been 25 minutes. Let me ask one question of all you, and then I'll take your question. How many folks here are working in Rust regularly right now? Okay, just a handful. Go ahead.
So first of all, I appreciate the talk because a lot of the stuff you've run into, I've run into already. But a couple of quick statements. One, I found that the crates that are there are more complete than the Go libraries. A lot of times you go searching through 5 Go libraries that all do the same thing and none of them do it very well. There's one crate that does it excellent. For example, I was using my people wrote a Go RPM utils.
Okay.
And it was the first complete Go RPM utils you can find in Go. I found the RPM crate the other day because I was rewriting some stuff from Python to Rust, and I found the RPM crate, and you can actually explode an RPM with one statement. And it was amazing how clean that crate was. So
Yeah,
my
nice.
question to you is that, so you talked a lot about your journey, which is, I went through the same journey several years ago, and, but how did the team react? Because I'm now implementing Rust for my Rust support for my pipelines, and I've got, on a team of, 40, I have 2 kids that have written Rust before, right? So how was the journey for the team?
Yeah, no, that's a great question. So I'm trying to, this sounds silly, but because this is related to something that AWS is doing that's not public, like,
You can talk in code words.
yeah.
Well, friends here.
So yeah, so interestingly, this piece of the project was joined to a broader initiative to a team that's already working in Rust, and that's why it made sense to write this component in Rust. So essentially, I was sort of brought in as someone, hey, you're a containerd maintainer, this thing needs to drive container workloads, what can you kind of put together as a POC? So I spent the early part of the year just kind of doing a POC. Now that team has sort of subsumed that as part of the larger Rust component they were already building. And so it didn't really involve transitioning people from Go to Rust, except for me.
Right.
So I don't know if that answers your question.
It does. I mean, you already had the elitists over here, and you didn't join them. You also destroyed the joke of, well, we'll just rewrite it in Rust. So what happened to me was, and maybe somebody else in here can relate, is that 5 years ago I was doing an event-driven system, and I was doing my POC, and I was doing it in Rust, because like you said, you have to have a project that is important to you to learn a new language.
Yep.
And so I'd been dabbling in Rust, but I hadn't really gone all in, and so I went all in, and I wrote the POC in Rust, and I brought it back to my team, and it was 5 years ago, so Go was hot. And in order for me to get help, I had to abandon Rust and go with Go.
Okay.
And so the project got written in Go, and I haven't circled back to rewrite it because I don't rewrite battle-tested code. Right? So I don't know if anybody else has ever run into that where you've done something in Rust and then you couldn't give me help on it. I just don't want to commiserate, pity party.
Yeah. Anybody else have experience like that or similar complication of? Yeah, I mean, so I don't have anything that relates directly to that, but it's interesting in the containerd ecosystem ourselves to have, there's clearly a group of the original maintainers who now are at different companies and who are obviously doing something in Rust that they can't maybe talk about yet, that, a lot of them built these crates. And so even our own containerd community is kind of a mix of some, we were all Go people, and now there's a subset of Rust people in the containerd ecosystem. I like it in the sense that I know that they're enhancing our Rust support as they continue to work in the Rust ecosystem. But even that makes for, it's like most of our core maintainers are not reviewing PRs in the Rust extensions repo, not because they're not willing to, but they're not really Rust developers, and so it's hard to make a solid, code review if that's not your language.
Yeah, definitely a problem I'm going to run into over the next year to 2 years. And then, I also have gone out of our way not to rewrite old tools that work fine in Go. Don't rewrite them in Rust.
Yeah.
If it's Java, rewrite it in Rust. I never want to see the Java again. But that's kind of how we're playing this out. And so, but my new tools will probably all be Rust moving forward, and I'm really hoping that Rust becomes hot like Go was 5 years ago, and everybody's willing to try and learn it.
Yeah.
I think did you talk about the learning curve? How was the learning curve for you?
Yeah, so like I said, I had 2 very failed attempts to learn Rust that were not based around work I actually needed to accomplish. And I feel like they failed because I found some of the constructs difficult to understand without having getting my hands dirty. When what's the what's the tool that you can run from the command line that actually tests, it kind of walks you through. It's basically the Rust book, but with like direct examples. Yes. So that was kind of a turning point because it's like, okay, now I'm actually having to open the editor, like really understand things. Because I feel like before it was just so high level, I was just trying to read the book and understand the concepts. And I think that was a turning point for me. But I feel like Go the syntax is simple. Most things are fairly straightforward. I feel like Rust has, more syntactic magic that took me a while. Yeah. Go ahead.
So, talking about reasons for swapping out Go components with Rust, like Docker pool, how do you justify that to executive leadership? If you're presenting to them, what sort of metrics do you track?
Yeah. So in this case, again, my personal case, I didn't have to make that argument because I was being told that the argument had already pushed toward Rust for the broader project that was being worked on. I know that in general, I've seen a lot of the discussion turn to performance, obviously the memory, safety aspect. So I don't know if, people know who Let's Encrypt is, right? ISRG. So they've been funding some actual rewrites. SSH, I think, now has a Rust implementation that the big news recently was Ubuntu is going to adopt it. Core utils. So they've been funding some of that through the same, ISRG.
I'll tell you how there's two ways to get your management to fly into Rust. I'm sorry to interrupt, but this is how I did it. We have a gaming analytics division, and they needed it to make money. So find a way to make it make money. And then the other one is that we have a bunch of government contracts, and CISA and NIST have put out several documents listing out languages that when you read them out loud, you're going to laugh when they say they're memory safe. But Rust is the number one in the list, and it's the closest to C++ and C that you're going to get.
Yeah.
Performance, size, speed. I tend to think it goes fast. It's not as fast as Rust. And it's definitely a larger binary. So if you're an embedded, cell size, so money, size, and the government said so.
Yep.
Thank you.
Yeah. Anyone else? Questions, comments?
Well, could I do a follow-up on that gaming analytics? What was the money justification for it?
We bought a gaming analytics company, and you got it when you acquire something, you have to make money with it. So.
But what was the Rust connection, I think?
Sorry. A bunch of their tools are written in Rust.
They
So
are.
I'm adding Rust to my pipeline finally after years dying to do it with no business justification. I now have a business justification.
I
We have a
see. But
division.
it's ancillary.
That has to compile stuff, and I don't trust developers. And so I don't want them compiling on their desktop, and we give it out to the world so that they can run in Fortnite. Okay?
Yeah.
I want it to go through my pipeline because it needs to meet the executive order, especially if it's going anywhere gaming-wise that might be I don't know if you know this, but the government sometimes puts out video games. And so,
Yep.
man, any chance you get to justify it,
Gotcha. All right, thank you.
Yeah. Go ahead.
I guess this is not directly related to the subject you covered in the talk, but just as we're having this discussion about migration from other languages, have you seen projects migrating from C++ to Rust? And specifically, I'm a maintainer of an open telemetry component written in C++, so I'm interested in learning.
Yeah, I personally have not, but I do know at Amazon, there's definitely, for system layer software, there is now a natural tendency toward Rust, and I know some of those components were C++ at some point. So there's other folks here I can connect you with that, that are driving kind of Rust at Amazon, and probably have stories about the C++ transition.
Yeah, I was in an Alpha Omega meeting, public meeting a couple of months ago, 3 months ago, where a bunch of engineers from Microsoft and Amazon showed in, and everybody was saying that, like, they had the common problem of like switching from C++ to Rust in some of their projects because it's mandatory, but then the lack of tool support, etc., and like how is there's a lot of pain in that
Yeah.
position
Yeah.
as well. And so there's like this discussion. I don't know what the solution, but definitely in Amazon and in Microsoft, those problems are being felt.
Yeah. Yeah.
Big organizations,
Yeah.
figure out, like where exactly.
Yeah. Actually, that triggered Prime Video. Their base layer was all C++. They rewrote it in Rust. And there's a London-based principal engineer who has given some talks on their Rust adoption. I can send you some of his stuff. All right, we're a minute past time, so thanks for the discussion. Hopefully the talk was useful, and if you want any of the resources or pointers to anything I showed, let me know. Thank you.